Ladies and gentlemen, welcome back to Engineering Dynamics. In this video, we will be talking about transformation matrices and how we can transform from one coordinate system to another, and how we can transform the angular velocities from one system into another. So let's jump right in. So we are given a carousel and we have three coordinate systems. So the first coordinate system that we have is, of course, the inertial coordinate system. That's here. Then we have a turn coordinate system, that is L, that is turned by angle alpha around the axis Z. And then we have a third coordinate system, that is coordinate system D, that is turned around the x-axis with the angle beta. And the first thing we want to know is how can we transform from one coordinate system to another? In our case, how can we go from L to coordinate system I? I have a visual representation here, so we can just look at that picture, but I think this is a bit clearer to understand. So we have our coordinate system I that is fixed, and we have our L's that is turned. To get the transformation matrix, we have first to take the unit vector in X in L, so it would be that one, and see how it is described in coordinate system I here. So here, of course, we have to go down, that is the cosine, so that's where the cosine comes from, and here we have the sine. Nothing is happening in Z, so that's a 0. We have to do the same thing for the unit vector in Y of L, so we take the unit vector of Y in L and see how it is described in coordinate system I. Here we have the angle alpha. So we go cosine in Y, so that is here, and we minus sine in this direction in X. And nothing is happening in Z, so we get a 1 there. Then we want to know how do we get from L to D. So from this coordinate system to that coordinate system. Here we have basically a front look, so we look from this side onto the disk. Then again, we take the unit vector x in our case, that is just pointing, so nothing is happening in x. Then we take the unit vector in y, our unit vector L. This is, sorry for that, it's, oh, come on, it's this one. And how is it described in D? So we have, in Y we have the cosine, and in X we have the minus sign. Then we do the same thing for our vector Z. So we take Z and L, that is this one here. This is here the angle, so we have cosine in Z and sine in Y. So we have a sine in Y. So now we know how we can transform from L to I and from L to D. Now we're interested in the angular velocities, because we know that the coordinate system L is turning around Z with alpha, and we know that the coordinate system D is turning around X with beta, so beta dot and alpha dot. So to transform the rotation around alpha and L, we need to write, first of all, this is our rotation because we're turning around the z-axis, and we want to go from L to I. And this is our transformation matrix that we got from here. And we see that our rotation of L in I is basically the same as the rotation of around alpha in L. So nothing really changed because we had to multiply this one with this angle, this vector. Now we want to know what is the rotation around in D around D. So first of all, D is rotating by itself around axis X, that was here. And we have a rotation that is happening before that. So we have the rotation around alpha. And now we need to transform the rotation of alpha of coordinate system L into the coordinate system D. And we do that by pre-multiplying that matrix. So we have alpha here, so we have the sine and cosine that we need to multiply it with, and what we are left is beta dot alpha times theta, alpha times sine beta, and alpha dot time cosine beta. Now we, of course, can also find out what our rotation of D is in coordinate system L. And we know that, well, L is rotating by itself around alpha. And now we need to transform the rotation of our coordinate system D into coordinate system L. So we pre-multiply it with our rotation matrix. We have a beta here, so we take the first vector, and we see that it's just a 1, so we're left with beta dot in x and alpha dot in y. So this was just a short video to give you a basic introduction on how we are working with transformation matrices and how we transform an angular velocity from one coordinate system to another. If you have any questions, you can ask them in the comments down below. Thank you very much for your attention, and see you next time.